Hello and welcome back. In this lesson we're going to be going over collecting like terms. Now in the last few lessons we went over solving one-step and multi-step linear equations. And in these next few videos we'll be focusing on different techniques that will become useful when we're trying to solve linear equations. And so in this video the technique that we're going to be going over is collecting like terms. So why don't we just start off with explaining what that is. So we have 2x plus 4x, and the question is, how could we combine 2x and 4x in the way that we do over here? Well, 2x plus 4x is equal to 6x. So it works in the exact same way as with basic addition. So if we just had 2 plus 4, we know that that would be equal to 6. The same idea, 2x plus 4x is 6x. We can do this one as well, so negative 3x plus 5x is 2x, just as negative 3 plus 5 is equal to 2. So if it helps, you can just pretend that the x's are not even there and just go over how you would normally do addition and subtraction in your head. But it essentially works the exact same way as it would with normal addition and subtraction. So for example, if we had negative 4x minus 7x, we know that that would be equal to negative 11x, just as negative 4 minus 7 is equal to negative 11. Alright, so we now went over what collecting like terms are. We're going to do two examples that use this new technique that we have created. So in this example we have 6x minus 2x is equal to 8. And we want to solve the linear equation. We want to find a value for x by isolating for x, getting x to be on its own. Up till now, all the linear equations that we were solving only had x show up once. We noticed that in this case, x shows up twice. So how do we deal with that? Well, we're going to use the technique we just established, which is collecting like terms. So 6x minus 2x is equal to 4x, just as 6 minus 2 is equal to 4. So we can rewrite that as 4x is equal to 8. But then now it's a normal linear equation that we're used to solving. So we know from here that we want to get x to be on its own, so we're going to divide the left-hand side of the equation by 4. That means that we're also going to divide the right-hand side of the equation by 4. We notice that the 4's will cancel out, and we will have x is equal to 8 over 4, or x is equal to 2. And that is our final answer. So why don't we do another slightly more complicated example. In this example we have 5x plus 9 is equal to 2x plus 11. So how can we change this equation so that x only shows up once? Well, once again we're going to be using our technique of collecting like terms. In this case we notice that we have a 5x on the left hand side and a 2x on the right hand side, so it would be really nice if we could group the x terms onto one side so that we can then collect the like terms. In this case we're thinking we can subtract 2x from both sides, because we'll have 5x minus 2x plus 9 on the left hand side of the equation, and on the right hand side we'll have 2x minus 2x plus 11, and we'll notice that the 2x terms cancel out on the right hand side, and we'll be left with 5x minus 2x plus 9, which is 3x plus 9, because you know 5x minus 2x is 3x, just as 5 minus 2 is 3. And on the right hand side of the equation we'll have 11. So notice that we realized that we need to move one of the x terms to the other side so that we can collect like terms, and that is why we subtracted 2x from the right hand side. Now we know we want to solve for x, and we know exactly how to do this because we only have one x term. So the first thing we can do is subtract 9 from the left hand side, which means we also have to subtract 9 from the right hand side. And so the positive 9 and negative 9 cancel out, and we're left with 3x is equal to 2, because 11 minus 9 is 2. We can divide the left-hand side of the equation by 3, and thus we'll also have to divide the right-hand side of the equation by 3. The 3's will cancel out, and we'll be left with x is equal to 2 over 3, which once again is our final answer. So those are the two examples that I wanted to go over in this video. As a recap, we went over collecting like terms, and we learned how it can be applied in solving linear equations. In the next video, we'll go over another technique that is very useful when solving linear equations. But for now, as always, thanks for watching.